In this video, I'm going to show you how to train a MASCAR CNN for nuclei segmentation. So now that we have defined the data, that everything is ready, I'm going to open the training notebook. And so again, always organized same way. We first load the packages, the codes, everything we need. And then we're going to define the parameters. As for UNet, we can define several, so we can do batch training, so define parameters for several trainings. I'm just going to do for one so far. So let's run it. And now we have all these different parameters. So similarly to what we had before, we need to define where the training directory is. So it's in nuclei training, and where the validation directory is. So it's in nuclei validation. Then we need to define an input model, because here we do transfer learning, so we need to use a pre-trained model to initialize our weights. So we're going to use a model that was trained on the COCO dataset. So I'm going to select MASCAR CNN and COCO. And then we need to define where we want to save the model, so we're going to save it in train classifiers. All right, and then as we do transfer learning, we can do fine-tuning. So we can, so I would recommend to do it that way. So first train the heads only, and then train the whole network. And so for each of these parts, we can define the number of epochs and the learning rate. So I'm going to keep it as is. So 1 epoch for the heads with a learning rate of 1e-3, and then 3 epochs for all network with a learning rate of 5e-4. And MASCAR CNN really needs a lot of data. So generally you're going to have to define, to use a lot of augmentation. We won't do any augmentation to start with, just to train it to see how much time it takes, and then we'll decide. So then we need to define how the image, the size of the image is seen by the network. So it doesn't have to be that size. It's the maximum size for either width or height as seen by the network. If it's larger, it's going to be resized, so it's going to work. And when we do augmentation, we actually change the size with MASCAR CNN. But as I told you, we have something that's about 256 by 256, so we're going to define it as 256 here. And then this is used if you don't have validation training, validation data set, but we have, so this won't be used. And I'm just going to train with these parameters. So we have 140 images for training and 15 for validation. Bunch of warnings, but no worries, it's going to work. It's just warnings. And then it's going to train just the heads first, and then the whole network. So I'm going to speed up the video because it takes a little bit of time. So you see, I'm just going to show you. So this is 1 epoch, because for the heads we only have 1 epoch, so it's 1/1. And now it starts. So we have 140 images, and so it trains these images first, the heads first, and then it's going to do 3 epochs for the whole network. And so I'm going to speed up the video now. All right, it's done. So let's just have a look at the messages here we have. So if we look back, we have a different epochs. So here, we had the 1/1, the first epoch for the heads, and then the 3 next epochs for the entire network. The number of images 140, the times it took, and then the losses. And if you look at it, we have a loss for class for the region proposal network, a loss for the bounding box for the region proposal network, and then another loss for the class for the MASCAR CNN, a loss for the bounding box for MASCAR CNN, and a loss for the segmentation mask for MASCAR CNN. And a global loss. And actually the global loss here is the addition of all the other ones. And then same thing for validation. So as with UNet, we can visualize the losses here with TensorBoard. We don't have accuracy because in that context, it's pretty difficult to define an accuracy as it depends on several things. the segmentation mask, the bounding box, and everything. So we limit it to the loss. And here we can look at the global loss. So we only have 4 epochs, so 0 to 3. And we can look at all the different loss, but it's going to be hard to interpret. So I would just recommend to look at the loss and the validation loss, and that's enough. And we can see that in both cases it decreases. So now let's do the same thing, but as I told you, mask-RCNN really needs a lot of data. And here we have so 140 images, 256 by 256. It's definitely not enough. We'll see what kind of results we can get, but I'm going to directly start the same training, but now with data augmentation. I'm going to define it as 100. And I'm going to run it. Thing is that it's going to take a lot of time, because you see here, sorry, if I go back to my curve, I can see that it took 9 minutes and 20 seconds without augmentation. So with 100-fold data augmentation, it's going to take quite some hours, probably around 15 hours at least, I guess. So let's see. I'm going to start the training, and then I will just cut the video and go back when it's done. All right, training is over. So we can look at the results with TensorBoard. So I'm going to go down. And now, as you can see, we have 2 different training. So the names, I'm going to show you directly how the names, so what they correspond to. If I go back to a folder, so the classifiers, so the new models trained are stored in this folder. And you have, so if I just expand this, it's not what I want to do. So it's as for UNet, the names depend on the parameters. So they have all the same parameters, except first one had no data augmentation, second one 100-fold. And you also have folders with name corresponding to when they were generated. So that's the first one, and that's the second one. So the first one actually corresponds to the one without data augmentation. If I go inside, I have the 2 files that are used by TensorBoard. And then there's there's actually a classifier after each epoch. So, it might take some room, so you might want to get rid of them. But if you wanted to go back and to see what the classifiers are after each epoch, to see if it really improves, you can go back to it, you can remove them. But what is important is that that's what you have in TensorBoard. So if you look at this correspond to this name, and this one correspond to this name. And that's why you have in TensorBoard. Of course, if you want to do a new set of trainings, you'll have to remove them or save in another location, so you can have a new set of curves. So let's go back to TensorBoard. So another thing, so we didn't change when we used UNet, there's a smoothing. So you can see here, you have a faint curve, which is not smooth, and a solid, so with plain orange, for example, for the smoothed one. For UNet, it made sense because we had many curves, and training was not, at least convergence was not super smooth. So if you don't use the smoothing, it's harder to look at your curves. Here we just have 4 epochs, so that's not useful. So I'm going to put it to 0. And we now have the actual numbers. So obviously the one with data augmentation has lower loss and lower validation loss as well. So we'll use this classifier for nuclei segmentation.